Okay, let's get started. So thanks again, everyone who's here. Looks like the audience size is slowly growing. So I guess we'll probably hit peak size somewhere after lunch. So let's kick off the autonomous transportation session. The title for this is, what's driving these autonomous vehicles? This is obviously a brilliant one. So on the panel here today we have Seshraj from Ganga, who's the moderator. His bio is, so over the last 35 years, Sesh has worked with a number of leading-edge Silicon Valley technologies in key technology and business roles with Fortune 100 companies and early-stage startups. These include supercomputing time-sharing in the 80s, which is basically now again cloud computing, VLSI CAD automation, intelligent team project management, CRM, data security, machine learning, and distributed cloud security architectures. Sesh's current company, DS Apps, builds distributed apps focused on next-generation smart city transportation. Upcoming products include new generations of V2I, vehicle-to-infrastructure platforms, designed for ensuring safety, security, and reliability of autonomous self-driving vehicles. And Seshraj, I guess you're a Ganga?
Ganga.
Okay.
77 batch.
Ganga guy 79 batch. All right.
77 batch.
77, sorry. All right. Then we have Ajay Bumala, Ganga. And which year? 96. Okay, maybe that sounds good.
Yeah.
Okay. So Ajay is a senior manager of hardware engineering at Waymo, leading vision, positioning, connectivity, and infotainment systems of self-driving cars. Before joining the self-driving car revolution, Ajay helped Google's entry into consumer hardware business, and he was an early engineer on Google Home and laptop product lines, which includes Chromecast, Google Wi-Fi, and Chromebook Pixel. Before joining Google, Ajay was at Racefan San Diego Research Center, acquired by Argon ST, which I don't know what that is. I'll take your word for it. And Digital Furnace, which was acquired by Broadcom in various R&D leadership roles. When he's not working, he enjoys biking, hiking, watching cricket, and spending time with his kids. Thank you. And then my favorite panelist today, Nilesh Kulkarni, Godav Aero 97, which is the guy in the middle. It's one of those funny things where when you go in the same batch, same hostel, same branch, you know someone in a totally different way. And then you see their bio 20 years later, you say, WTF, man. How did I get all the stuff done?
So, he knows all the secrets.
Among other things, Nilesh, who used to go by the nickname Kundi, we also shared like a room in our IT in Goa, which obviously created many memories also. So anyway, so Nilesh Kulkarni currently works as the director of AI at Neo Inc. He received his BTech from IIT Madras in '97, an MS from the University of Alabama in '99, and a PhD from Princeton in 2007. From April 2004 to May 2012, he worked as a senior scientist at NASA Ames Research Center, focusing on intelligent control applications for flight and space systems. He was a lead for the control algorithms development for the LADEE Lunar Orbiter mission. From 2012, he has focused on data science applications, working at consumer startups, where he served as the principal data scientist and director of data science in the personalization of their consumer services. In September 2016, he joined Neo, where he has explored personalization of the in-vehicle immersive experiences, including music, podcasts, videos, etc., along with building out several vehicle health applications. Currently, at Neo, he is leading the traffic modeling effort at Neo, leveraging machine learning algorithms for producing real-life traffic behavior for the validation of L4 autonomous driving software. And then we have Subbu Anandaraj, or Krishna, which...
Krishna.
Oh, Krishna, okay. Oh, Krishna in the hostel, I thought it was
My mother name is Krishna.
Okay. Man, because everything else is, moderator, Ganga, Goda, they all make Krishna. Sorry about that. So Subbu is the lead system software architect for the autonomous driving group at Intel. He is leading the systems design and development from the Chandler Vehicles Lab to fuel level 4 and level 5 autonomy using Mobileye's next generation platform. He designed and developed the world's first collision avoidance consumer drone called Typhoon H. Yeah, okay. Demonstrated the same at CES 2016 and won the Best Product Award. He demonstrated one-of-a-kind LTE connected UAV, unmanned aerial vehicle concept in the Mobile World Congress, MWC, to fuel the AT&T Intel collaboration. Fun facts, he developed multimedia components for the mobile devices at Motorola for more than a decade, so Moto Razr to Moto Droid Razr. He also has an FAA certificate for commercial unmanned aerial vehicle pilot, in short, a drone pilot. It's pretty cool. Yeah. And then finally on the panel we have T.R. Ramachandran, who is actually from Saras, the hospital. Yeah. Right. So T.R. Ramachandran is a Silicon Valley veteran with engineering and senior management experience spanning a variety of products and technologies across semiconductor systems and software. T.R. Is an IIT alum and has a PhD from USC. He's currently the Vice President of Product Management at Velodyne, which is a market leader in LiDAR sensors for autonomous vehicles, mapping and other applications. Outside of work, TR's interests include specific areas in climate change, renewable energy, transportation, and media. So thank you all for being here today. And with that,
Thanks a lot. Thank you for the introduction. So again, I'm Sesh Raj, IIM 77 batch. It's an honor to moderate such a panel of such an illustrious set of panel members. And Ajay, Nilesh, Subbu, and TR are top-notch technologists and leaders in building and driving new advancements in autonomous transportation technologies. In the last 35 years in Silicon Valley, I've been part of many leading technologies and seen the ups and downs and ups. So right now we are really seeing the launch of a massive new industry. This is a real massive industry, and this may dwarf the PC revolution, the internet revolution, the mobile phone economy. An Intel-sponsored study had this market, this economy at $7 trillion in 2017. So I don't know if it's true or not, but it's a very huge, market. And it's like, if you knew that if you could buy Amazon at $1, so that's where we are right now, a huge market. So the technologies needed to make this happen, make it happen have matured, and cities around the world need this desperately. So they want to revamp their transportation architecture, infrastructure, solve congestion, and save millions of lives. So our discussion today will focus on what's driving these autonomous vehicles. So we're going to be looking at behind the scenes, looking at the advanced technologies that make it happen. So let's first begin with a quick survey of the audience. So how many of you are already involved in some way with the autonomous transportation industry? And then the next question is, how many of you are primarily technology focused, which means you are either looking for a career in this industry or looking for maybe doing a startup, building a product which will work in this industry. So technology focus. Yes, absolutely.
You're looking,
already in that. How many of you are technology focused? Yeah? And what about business focused? Sales, marketing, and so on. And what about investment focused? Because this is a great time to actually be looking at the right investments. So, and finally, how many of you are skeptical that this industry, the future of this industry, think it will be more than 5 years before it takes off? You've got quite a few skeptics. Great. So the plan really is, we're going to go through a set of questions, and these are the real experts. So I'm I'm going to sort of bring different questions, and then we'll sort of go around, and they'll answer. So first thing is we look at the state of the industry. Let's begin with understanding, what the state is. Silicon Valley has been accused of driving the hype machine, especially now with this documentary on HBO. So driving the hype machine with products and technologies announced before they're ready. So let us hear from the panelists, where do we stand? What is hype versus reality in this industry? What is available here and now? And who are the customers eagerly waiting for this technology? So, we can take in any order you like.
I can go first. I guess the space is so big, right, and large, right, applications ranging from many levels of safety, right. So today we can see this in a lot of cars already, right. They have like assistance to the driver, right, to either brake when there's a collision that's going to happen, or automatic cruise control, right, trying to take you on some of these highways. So the technology for some of this is already in the market, right? But maybe a lot of the hype is like, when do we get to not having any driver in the car, which is like the long-term end of this problem, which has a lot of challenges. I think we're going to talk about it later. But across this space, there's a lot of challenges that will also be discussed in the panel. But fundamentally, I would say like the investments are going on because it's a big industry and it has a big impact to the society in general, right? So I think that's where a lot of investment is going on. And the other side of it is the car companies themselves haven't been innovating in this space for a long time, right? So you see a lot of that is a catch-up to bring these technologies faster to the space.
So I can give a little bit of a historical perspective here, right? So I think essentially it started as a robotics problem, right? And one of the successful applications I would say of this was, is Mars rover. So if you think about it, Mars rover was sent out, I think the mission lasted several years, and it was managed by JPL. And it operated in extreme conditions, in extreme uncertainty, I would say. And it was fairly successful. And it sort of started from that aspect coming, and then Google started with the self-driving project, where I think there were a lot of skeptics basically, right? And so they sort of laid the foundational work. Beyond, in the same span of time, I think a lot of push happened with DARPA grant challenges, which were set up, which actually a lot of the teams participated, the CMU team and Stanford teams, and a lot of academia got involved heavily into this area. And then sort of, I would say Tesla was sort of a pioneer in actually getting it on the road, getting people used to the concept. I think I still feel one of the challenges is in terms of us being able to let go at speeds where you're effectively putting your trust onto a system. Personally, I like to be hands-on in everything in my life. And this is something that's very difficult. So I think that is a big problem. And then after that, there were sort of, I'm saying, I feel a lot of innovation has happened in the Silicon Valley, I would say. And then Detroit is sort of now suddenly woken up and playing catch up. And then they sort of tried to get a foot into the game by acquiring a bunch of startups, right? So the example being GM bought Cruise for $1 billion. And then there's a lot of activity happening even in Europe. For example, BMW, Audi, all those players, Mercedes, are coming up with their versions. And in fact, I would say that so in terms of autonomous, all of you would have heard there's these levels of autonomy, starts from level 0, level 1, all the way to level 5. Level 5, you might not even have a steering wheel. Level 4 is where everybody is trying to push to. And right now Tesla is, I would say, at level 2 in some ways, and so on. So a lot of the European players are getting into this level 3 space, which is sort of, it's autonomous, but there will be, if it feels that it doesn't know, the vehicle doesn't know what to do, it will in some way provide a signal to the user, and the user is supposed to take control of the vehicle. So there is a bunch of OEMs that are all on the bandwagon of autonomous driving now, more or less. And then there is a big support infrastructure in terms of all the companies, the sensing, the data infrastructure to support this massive problem. And it's become a big industry.
Yeah, I think I can add on top of it. What is driving, right? So where is the money? Yeah.
You know, regarding the automation levels, so we have got a slide up there, which, so that we can keep coming back to that. Thank you. Go ahead.
Yeah, what is driving, right? So the money is in the star rating. So when the car manufacturer can sell more car by saying I'm a 5-star rating. So not by adding another sensor or bringing another technology. So there is a trade-off between the technology versus the solution, what we can showcase. So there is a transition happening from level 2 to level 5. So level 4 and 5, again, it's not dreamland, and there everything is robot can take over, and we can do hand off, mind off, and so on all scenarios. But today's, like Ajay mentioned, the automatic cruise control or maintaining a distance, these are just an ADAS, just a assisting system. So that's where the hype versus the actual reality. So if you look at the solved problems or the vehicles, they are not vehicle anymore. It's totally robot. The form factor, the fuel efficiency, the look and feel, it's totally changed. So it has to be revisited. Yeah, I think that. Yeah, we'll continuously discuss.
So when I think about hype versus reality, this is actually a useful chart to answer that question. As Nilesh said, Tesla today, or if you have GM Super Cruise or any of these features, they work really well in a lot of conditions. That's level 2. Right, so today we have cars out there that are already essentially doing some level of autonomous driving over restricted conditions. Level 4 is what the Waymos and Cruise and GM, Argo, Ford, many of these companies are trying to introduce a level 4 capability where the car can essentially drive itself. Again, not necessarily in every condition everywhere, but a substantial part of normal human driving conditions, right? Now, when you read some of the stories about, well, okay, the self-driving car couldn't quite, do the whole drive without human intervention. Essentially what's happening is, as the level 4 teams are trying to build that perfect level 4 vehicle, they're occasionally going into level 3. So level 3 is when the car is driving by itself most of the time, but at some point you may need a human to intervene, right? So today's level 4s, therefore in the worst case, are already at level 3, which is actually quite amazing, okay? Now, when you think about level 4 itself, you have to group it. I like to group it based on speed, okay? For example, we have some customers who do low-speed buses or robo-taxis. These are primarily in urban areas. They generally don't go faster than about 25 miles per hour. And They have several that have been running completely autonomously for at least a year, maybe more. Okay? So self-driving vehicles already exist. So if you think about it that way, I don't see it as hype. But if you think about it as, okay, I'm going to have a self-driving car that can drive everywhere, urban, city, highway, all kinds of conditions, New York traffic, jaywalkers, everything, and handle everything perfectly, yes, that will take some time. Because it's that last, maybe, Ajay has probably a much closer idea of this, but maybe the last 2 to 5% of the situations that humans encounter, which needs a lot more practice for the AI and for the algorithms to figure out what to do in those circumstances. Should I stop? Should I go? For example, I was talking to someone at Uber who was saying, the two biggest challenges for self-driving cars are to decide when to start moving and when to stop, right? So he was half joking, but the point is you run into situations where, you have, let's say, maybe a plant jutting into the road, okay? Do you have enough intelligence and learning to know that's just a plant, you can brush by it and you don't have to come to a stop because something is jutting into the road, right? So these are what I like to call as last mile problems. I believe that over the next approximately 3 years, the vast majority of those problems will get solved between a combination of hardware and software, and that's what many of us here and a lot of other people are working on to enable and address that last mile challenge. So I would say, I don't necessarily think it's hype. I think, yes, some people may hype it up to more than it is, but I see it as making very logical steps towards getting to level 4 from a ride-hailing standpoint and commercial vehicles, and level 3 for retail vehicles, cars that you and I will drive.
Right, and just to add to that, driverless shuttles are already being ordered and starting to fly even in the Bay Area. And there are
That's right.
driverless trucks in Texas which are already flying. So it's getting away from hype actually.
That's good.
So okay, the next is we're going to start going deeper into technology. Deeper dive. Sorry. So we'll now go, we'll do a deeper dive into some of the technologies that make this happen. So we'll hear from these panelists on what is latest in development and what is available here and now. So the focus is here and now. It's not like, And what are the state of sensors, for example, the state of artificial intelligence algorithms? How will these vehicles find their way around? Are there going to be new types of maps? How will these vehicles communicate maybe to each other? What are the new trends and levels of automation? And will we have to wait forever to see these technologies being applied? So, Ajay, you want to start? Actually, you guys can put any order.
Sure, I'll get started. So, in terms of sensors for self-driving, and each of them will have pretty unique perspectives. One of the key enabling technologies that has really made level 4 more of a reality is this sensor called LiDAR. Light detection and ranging. It's like radar, but you replace radio waves with light waves, infrared. So LiDAR is a key enabler because you can essentially, with a LiDAR, if I just mount one in this room, in fact, some of our customers do that. They're in the mapping business. So just to give you an idea, you can take a LiDAR, you can attach it to maybe a tripod like this, or just a stick. You can walk around this entire building, maybe in about 20 minutes, and you'll have a complete 3-dimensional map, indoor map, of every room, every corner, accurate to within 3 centimeters. Okay? That is what LiDAR enables. So if you put that on a vehicle, it's going to tell the vehicle, okay, I know everything within a certain radius. That number could be 100, 200 meters or so. and I can tell you exactly where everything is in that radius at what distance. So that is, that's been a transformative technology for this industry. So now you couple that with cameras and radars, which have been around for quite some time, and companies like Mobileye have been really innovating in that space for many years. So like a Tesla, for example, or a Super Cruise, they use cameras and radars, right, primarily. So they've been able to advance the state of the art with level 2 with that. Some of them, like Tesla, are trying to get to level 3 also with just that technology. I'd say most of the rest of the industry believes that you need all these sensors in order to get to level 4 or even level 3. So LiDAR is the newest of these technologies as applied to vehicles. LiDAR itself is not a new technology, but as applied to vehicles, it's relatively new. It's about 10 to 15 years old. So there's a lot of innovation going on to dramatically reduce the size of the LiDAR, reduce the cost of the LiDAR, to make it much more usable on a mass volume level. So Velodyne is in many ways leading that effort. There are lots of new companies now in the space. So I think as that technology matures faster, which will happen over the next 2 years, it'll extend the number of vehicles that can actually get to level 3 and 4. That possibility is going to grow exponentially. So I'll stop with that and give the others time.
Yeah, I can talk of it, thank you. Yeah. I think what is now, right? So today, if you look at it, the Tesla we're talking about, it's an highway driving partner. So it just just helps you to reduce stress and fatigue. It's not going to totally replace our driving. So that's where the sensors we're talking about. They're trying to come up with a camera-only solution or LiDAR-only solution, or can I put totally radar solution, or go to 5G to connectivity, no sensors. There are many ways to solve this problem. But each sensors have their own problem. Like we use human eye, which is baseline is very short, we can only see so far, but we can perceive the distance. Similarly, LiDAR, same thing. You can get a depth right away in one shot, but you miss the texture and the color details. So that's where camera helps. So we need to bring all the sensors together, like GPS. If you go under the tunnel or some of the dead zones, GPS cannot help. So lot of innovation, exploration going on in these spaces. So sensor fusion, yeah. So if you look at only camera only solution, will fail miserably if you have an auto exposure problem or driving on the hill directly looking at the sun, or if you have a LiDAR or other sensors, they can get easily fooled by the shape or the snow. Still, weather conditions need to be solved. So that's why if you look at most of the exploration happening in Arizona, California, and Texas, because of the weather condition, you rarely get to see snow. And so that's why the level 4. Level 4 is the max you can go, because the robot need to know the world. So today we cannot put the robot in an unknown world to navigate by itself. So it's a lot to happen. So it is.
So I'll kind of take it, since we started in the right place, sensors. I think I'll take it to the next stage, right? So once you have all this information, what do you do? Right. And so I think it feels very strange to say this, but Krishna is sitting here. I was a TA for him for a neural networks course in 1999. At that time, Simon Haken's book had just come up, and we were doing backprop and all of these different kinds of networks to solve various different kinds of problems. And they were sort of restricted to maybe 2 layers, 3 layers, and so on, because the functions that you were trying to capture, the inferences you were trying to make were fairly straightforward. But over the last, I would say 10 years, a lot of innovation has happened in the space of neural networks around image recognition and general this class of problems with LiDARs and so on. So there's so much data that is generated out of these sensors that there has to be a way of detecting the objects and sensing modalities that we have to have that done in real time. And so that has been one of the biggest enabler, I would say. And then parallelly along with that, other thing that has come up where we are today, I would say, is because of a lot of the internet age, where a lot of our big data solutions and infrastructure were created more for consumer industry. But now all of those technologies are leveraged for training and testing and all of these data pipelines that are created. If you look at some of the new systems that are coming up, just listening to NVIDIA's announcement on GDC on their data factory, maglev, Constellation Drive, these are some of the systems that they are coming up. And Waymo is another leader in this, of course, is the amount of data that is managed in a very efficient manner for training and testing these models is phenomenal. And then, so that is something that has happened over the last 10 years, I would say, which is one of other primary reasons beyond the sensors, which is making this possible where we are today.
Ajay, want to add something?
Yeah.
This is on the deep dive technology, especially what.
So I mean, yeah, I think individually, if you look at it, all these pieces exist, right? Or at least we know that how to make them, right? I think the challenge is in putting it all together in a reliable fashion, right? And that is the hard part. It comes to training, right? So taking all of these large sets of data and you have to train all your models. That is one part of the problem. You have to deal with a very wide range of environments, right? Like you have snow, dark light, right? You have to deal with fog, right? Every one of these sensors works well in some conditions, but not in all the conditions, right? So you have to be able to take multiple data inputs and be able to process that. And then, like, once you build a system, right? I think I was talking to Nilesh a little bit before this as well. Is how do we know that what we built is actually good, right? How do we even quantify that it is actually good enough? Is a huge challenge that we face. So yeah, I guess like where we are now, we have all the pieces of the technology, but I think we're still struggling to figure out how do you put all of this together into a thing which will run 99.999% of the time, right? Like every 9 you add, the problem gets bigger and bigger. So that's the key problem, I think.
Yeah, in fact, that leads to the next question, which was on challenge. So, because the primary rule in engineering is, Murphy's law: if anything can go wrong, it will. So, with millions of lives at stake, this is serious. And so, what keeps you guys up? And I think you sort of answered it, but what are the challenges? How do you handle systems that may fail? Like this, we have seen this Boeing. So, what kind of parallelism? AI may go wrong. Where the pilots were fighting with the AI system, and maps and navigation aids that don't cease to work. For example, when I was coming this morning, my map wasn't working. I don't know why. So, all the things that go wrong, and how do you plan to?
I can start off a little bit because I started talking about the problems. So, one thing is, clearly redundancy is one way you can address some of this, right? Like, so you can add dual, airplanes do it today, right? They all have redundant systems. They know how to manage this, but it comes at a cost, right? So, but I think the bigger challenge is even if you build redundant systems, knowing when your system has failed, right? Because with no human there, like, you now need to put detectability of your system into figuring out, like, hey, is my LiDAR working as well as I'm expecting it to work, right? Invariably, systems will fail, but we need to add these multiple layers of detectability fault tolerance mechanisms into these systems so that we know how well they are working, and when they do fail, what we need to do, right? So I would say like that is one challenge. I think we cannot plan for an L4, L5 type system where we cannot expect that every system will work without a problem. But I mean, like cars do run with no redundancy on wheels, right? But we know, I mean, but if you can make the reliability good enough, right, where it will happen that far, you can actually make the case that that I don't need redundancy. But to prove that is also a very, very hard problem, right? So that is definitely a challenge.
So what keeps me up at night is more, as Ajay mentioned, is the validation part. And there are different ways to solve it, and we have to put all of those together. And one of the things that you mentioned was fault tolerant systems, and that has to be there. At the same time, you have to recognize that this is the problem of validating an autonomous system is really a rare event problem. So there are some stats that NHTSA, the National Highway Transportation and Safety Administration, which does a lot of the rules and so on and so forth in the US, has put forth. So it was quite surprising even for me. For example, when you see numbers like, if you think about $1,000 worth of damage that would happen in an accident. So if you look at a class of accidents where at least there is $1,000 worth of damage, there is roughly 530,000 miles so an incident would happen every 530,000 miles. If you look at a fatality, actually, it's roughly happens every 100 million miles. So the situations and the scenarios where some of these things occur, they happen if you think about, so getting into a little more technical, if you think about probability distributions, it's a very long tail problem. And how do you capture that long tail in a very efficient manner? So that is where we are. I think at this point, I think a lot of the problems around sensing, around training, around data infrastructure are more or less, I would say, solved in some ways. I mean, we are going to keep on increasing the operational, ODDs as we call them, where the vehicles can operate. But how do you solve the problem of validation where it's really a rare event problem? And so if you think about, there's a lot of studies by RAND Corporation, by various academics and so on, which have stated that you probably need at least tens, if not hundreds of miles to really certify these systems. And so if we go with just those vanilla numbers, it will take years and years. But over the last, I would say, 3 to 4 years, I've started seeing, for example, PhD theses coming out of Michigan and Stanford, MIT and CMU, where they are specifically attacking this problem of how do you validate certain things where you can zoom in into areas that are more critical. And which is, if you can validate those distribution spaces in your probability distribution, you can make a real impact in getting these systems validated. So I think that's kind of an interesting space that I'm looking at.
Yeah, I can add on top of it. So mainly, looks like if you think about it, it's solved problem. If it is that only robot has to drive or the cars has to drive with another autonomous car, it is solved. So the main problem or the things keeps us busy or keep us continuously go forward is the coexistence. We have to coexist with the human driver. If you look at the day-to-day negotiation, it's like a verbal, it's a conversation between the other driver. So if you want to change the lane or if you want to take an exit, you are continuously having a conversation. You go a little bit, cross the lane, see if the guy allow you to go through. So these are like rightly mentioned, it's a statistical problem. So you need to be agile as well as safe, right? So it's like a balance act. So how do we solve this? So can we go like, because it's only an XY problem, so if there's no, maybe we can talk about flying cars, but if it is autonomous cars, it's only X and Y. So if you want to continuously proceed, so what we can guarantee is the car has to, the technology has to guarantee the accident is not initiated by him. I think that's exactly even our licensing procedure. So if you are in an accident, if somebody come and hit you, it is not your at fault. So we need to do the same for the car. Similarly, if you kill somebody in an accident, it's acceptable than the robot killing people. So these are the norms. We need to somehow come up with a common understanding or trying to quantify what kind of accident this car has caused. So there is an interesting standard evolving. It's called RSS, Responsibility Sensitive Safety. So what is the responsibility of the technology which is driving this one, and how much safety, and then how sensitive it is. These are probabilistically we can claim that this car is not the reason for it. So how are we solving? There are EDRs and other sensors we are installing in the car to address them. So I think mainly the coexistence is the major problem which drives this crazy.
And here, challenges keeping you up.
Yeah, I think between Ajay and Nilesh and Subbu, they covered many of the key things. Maybe I can give a couple of anecdotal points to elaborate, right? So if you look at a sensor in today's cars, so any cars we drive, typical car, maybe you've got a 5-year warranty, maybe 50,000 miles. Some of them go up to 100,000. When you're talking about a self-driving vehicle, the goal is really to drive this about 20 hours a day over, let's say, 360 days a year. Okay, that's about 7,000 hours through the year. If you assume it's driving at an average of about 30 miles per hour, that's 200,000 miles in 1 year, right? Not 50,000 miles over 5 years or 100,000 over 10 years. 200,000 miles in a single year. So part of that challenge is the sensors that go into the vehicles need to have that extra level of robustness to last that much longer, right? So that's a problem, we're aware of it, and there's obviously a lot of work going into making sensors more robust. The second thing which Ajay said is, I'd like to think about it as, there's a term in the auto industry called functional safety, which is the sensor has to communicate what its state is to help the car determine if it's working correctly or not. So in the case of, for example, a LiDAR or radar, it might be something that the sensor says, hey, I've checked my internal status and I have this one thing that isn't working correctly, so you need to know. So you have to factor that into your driving decision, that I may have a malfunction here, or I may have a 10% error in the numbers I'm returning to you. That's going to happen over the next 3 years, pretty much to cover all the sensors that are in the car. Okay. The third is the software. You can obviously do a huge amount of training, reinforcement learning. You can do a lot of those things that help, but I definitely would echo Nilesh's point about the validation challenge, because even if you have a system that's maybe about 10% more automated than a average human driver, if you want to statistically prove that it is safer than humans driving, okay, as he was saying, it's that if your fatalities are happening only once in a million miles, you would need to drive several billion miles to prove that you don't have more fatalities than today's human drivers, right? Which is impractical. It's like going to Neptune and coming back. So there has to be innovations that Nilesh described on how do you come up with new ways to find those problems that are likely to be encountered and more aggressively test to them. So that, I think that's a great point. And then the final one I'd say is also about what is society's tolerance for the failures of these robots, right? Ultimately, yeah, there will be failures. It's not going to be, it's perfect, zero, there's no problem. The question is what level of tolerance. These cars and vehicles are going to be much smarter than humans in vast majority of cases, but there may be these, 2 or 3% of cases where just because it takes time to mature, it will take the robot to become more intelligent than the human. So, and that each society has to decide.
Yeah, and they have done a study saying that actually more than 1 million people die every year from road accidents throughout the world. And this can cut down by 94%, the statistical 94%.
That's right.
So it's a huge number of lives here. So in any case, we've been told to go to the Q&A.
Sure.
So this is the time for you guys to get involved. So, look forward to some tough questions.
Yeah, so I think we just probably have very popular.
Okay, so here's the good thing, right? We've got a lot of questions. We also got lunch waiting on the other side. So I would appreciate if people can ask short and quick questions, and the panel can respond accordingly, and then you can take it off over lunch. Thank you.
So if you see current model, right? I mean, Tesla does the cars plus the self-driving software. Waymo kind of like the Apple, right? And Waymo just does the software, kind of like Android, and there are mapping softwares, there are sensors. So when this market matures, how do you think the ecosystem is going to look like?
When you say ecosystem, you're talking about who all the players are going to be, or?
Is it going to be more like, the car manufacturers doing the self-driving itself, or self-driving coming from somebody else, that sort of
So
thing?
I can say that there's 2 or 3 models that are running now, right? So every OEM is in a race to get a vehicle out that is self-driving. So that's going to happen. There are other players, robotaxis and so on, that are in the play. If you look at it, one of the biggest department, I would say, or money sink that Uber does is in autonomous driving. The massive infrastructure that they have provided for this project. So Lyft, Uber, all of these the ride-sharing companies, they are getting into it. I would like the rest of the panel to comment.
Yeah, I'll add a note to this. I personally think it's a little, while it's very clear who is getting into the market, I mean, there's a reason why ride-hailing companies are sort of, in many ways, leading the jump into level 4, because it's going to make ride-hailing costs plummet. Right? It'll make it cheaper to just, use a ride-hailing vehicle day to day instead of owning your own car. Let's say in 5 to 7 years. What is less clear to me, and I think there's some debate, and having talked to many people in the ride-hailing industry, is ultimately who's going to own these vehicles, right? Because there's a capital cost, there's a potential, there's the liability, insurance, etc. So it's not yet clear. Ultimately, the ride-hailing companies may be like the, Androids or iOSs of these cars eventually. At least that's how I'm thinking. They may or may not own their own vehicles. Even the car OEMs, they may build self-driving capabilities for their vehicles, but it's not clear if they'll own the vehicle. So, in my opinion, I don't think it's a completely decided exactly who the providers are going to be in the future.
I can add some predictions. Yeah. If it's all going towards mobility as a service, right? So it's all going to be service-based. Uber going to make the service business, it will go on. But if you look at the technology, it's a 3 major piece. The sensing, and then the planning, and then actuation. Actuation is taken. It's already the car manufacturers knows very good controls, motors, and so on. And then the form factor. That's a vehicle manufacturer. And then the sensors. Obviously, the sensor already many sensor vendors like Reliant and Mobileye on cameras and so on. They kind of excel on those pieces. There are yet to explore is the planning piece, the autopilot. How many miles this auto, the Boeing or any, we claim by the number of hours this autopilot has been tested. How many scenarios this pilot saw this world. It could be a next chip manufacturer or the FPGAs or one of the compute guys want that one. I think that's what I think of.
Yeah, I think next
Yeah.
question.
So I have not used cruise control, even though it's around for decades. Right? We are talking about technology. What are the 3 things or the inflection point to increase the customer confidence for mass adoption?
I can empathize. But I used to drive my dad's car in Mumbai, and I still remember after you are on the road for an hour. When I come home, my ankle would be just aching because you're constantly doing clutch brake, basically, at 5 kilometers an hour. I think those are some of the situations where it is not very critical, where speed is not there, where you can add a lot of value. You get your time back. You're not, you don't come home completely drained, basically, right? There are other scenarios where it adds a lot of value. So for example, there's a company called Voyager, which is looking at autonomous driving for retirement communities. Again, it's a very enclosed, constrained space. Your speeds are slow. You have completely mapped out that area. You have restricted the domain, and you add a lot of value to people who cannot drive, and make their life better. So there are several spaces there where in constrained domains, I feel that we as people, and Tesla has been sort of testing this hypothesis, if you will. And people are getting used to that. It was surprising, but people are used to it. But beyond those, there are several operational domains where I would feel that we would be able to let go in some ways as we start interacting with these vehicles.
It's like elevators. We get the elevators all the time, right? And they do it automatically. So once cars become like elevators.
Yeah, I guess that's a good analogy. So people used to have people who used to control all the buttons in the elevators. There was a man always there, right? Guess you can hear me. But over time we have gotten used to it, right? Because we just feel like it's much more safer, right? I think the same thing will happen, right? If, for example, you don't have as much doubt about sitting in an Uber car where somebody else is driving that car, right? Today, like you don't know that it's a good driver, right? You don't know he can, like, that he's using what technology he's using, right? But you have built up a confidence that I can go and sit in another car and he will take me from point A to point B. There is a risk, right? But it's a calculated risk that everybody's taking. And it's the same thing with technology, like the way where everybody draws the line of how good it is to adopt it or not is going to vary from person to person. But if it becomes good enough where by default it can be turned on and you don't have to think about it, it will just happen, right? If, for example, there are a lot of things in your car, you don't think about it because you're not even given control to the engine, like how it's firing or how it's driving the motor, right? So if you make it good enough that you don't have to give control back to the people, right? It naturally will just happen, right? You don't need more confidence.
First of all, great panel. Thanks for the discussion. I actually had multiple questions, and I'll just stick to maybe 3. And in the interest of time, you can decide which one to answer. And it's kind of similar to the topics you were touching on. So the first one is sort of that society adoption. In the chase for perfection, you really need to get to perfect or get to better than the next human, right? And in terms of a barometer to gauge, whether you've reached the tipping point, would you say, and tying back to the earlier panel, liability insurance premiums coming dramatically down when you get to the L3, L4 kinds of things? That's question one. Question two is, when you have systems that fail over to the human, either because of an imminent sensor failure or you've got a scenario you don't understand, doesn't that really put a real tax on the human reaction? I mean, similar to this 737 MAX 8, right? The pilots didn't know how to react, and why would that happen in this industry? And so is it really training the human that becomes the issue? And the third one is more about regulation. You have different commercial auto manufacturers chasing this lucrative business, and when there are failures, you do have an accident, let's say, right? And it was a Volvo car. How is that learning from that accident shared with other manufacturers? Do you need a regulatory body to make sure, enforce that training as opposed to having it as a strategic commercial advantage?
I have a request for the panel. If you could pick one person to answer each question, that would help us. Okay, thanks.
Yeah, go ahead, actually. Just a third one on the regulatory. There's a disengagement report which State of California puts out. So all the manufacturers that are saying that it tells you when the car stops working.
That's right, yeah. So the one downside of having 3 questions is you may not remember all of them. So I'm going to try to remember. But I think the bigger, your points are well taken. To a large extent, if you think about how different ride-hailing companies are approaching it, they're very thoughtfully sort of trying to address the core question of how do you get people comfortable enough by taking different paths to market, right? You have companies like Navia who are doing shuttles in dense urban areas, office environments, or May Mobility. And their goal is, it's going to be slow, it's very contained area. There are other companies like, let's say Cruise is saying, I'm going to go to the densest parts of city, San Francisco. I'm going to master that. And if I can figure that out, I can then extend it elsewhere. Waymo has their approach. So each one is taking, Nilesh mentioned Voyage. So each of them are taking an approach in this manner so that they can really get an understanding of what works for that community of people that they're servicing. And so you don't have to solve world hunger all at the same time or world automation all at the same time. You solve it here, you have a problem, you've solved it, you build confidence and you move forward. So I personally think that's the approach that makes sense, and that's what will allow this to scale over time. You're not going to suddenly see one solution, oh, it works everywhere, great. It's very unlikely. It's much more likely that you'll have different providers, they build their learning, they move to the next level and to the next city or the next zone. And through that experience, I think they'll build confidence within the local communities that they serve. And as that confidence builds, that will carry over when they go to the next community. At least that's how I'm thinking about it.
So I can take the third question. I don't remember the second question. But the third question, the easiest one to remember, was that manufacturers have, so the question was around
Sharing
data collection and sharing data, basically. So every company is involved. I know that NHTSA has requirements, for example. We are a Chinese NEO. And so we know that, for example, there are certain critical systems like your battery, your electric systems, the powertrain and so on. Those signals actually at a low frequency have to be broadcasted to a government cloud, basically. So that safety and there is some oversight on any critical systems as they deem critical. So for example, the battery can catch fire. So for example, they want to know what's the state of these batteries constantly. Tesla, if you know, has already, even Waymo, they have basically mastered this, where you basically collect the data around critical events. Every company is doing that. So the interesting thing, the problems that happen that are interesting is how do you figure out what are interesting situations. So there are algorithms that are being built that would identify based on a particular sensor input, which would say that this is something that we have not encountered before, I'm going to start collecting data. Now that would involve all kinds of different situations. And these, now the cloud is at a state where we can collect all these data and analyze it and post-process and so on. So I think that part of it is fairly resolved.
I can take the second question. So I think it is true, like when do we know, like do we have to train people if they are in L3 and when they have to take control back, right? That is a really hard question. It was actually one of the things that Waymo why doesn't do L3 and below is actually an experiment that happened where we gave a lot of Google people an L3 car and asked them to drive from home to office every day, right? And they were told they have to take control of the car when it was born. And invariably people got so confident that they would be doing other things and not take control of the car, right? So when will this transition happen is very hard to know, because when you're using the car 90% of the time manually and 10% for all these control features, maybe you're still okay taking control back. But when maybe that goes to 80% car, 20% human, then we never know, right? I mean, but will you really take control or not? And so that transition from 3 to 4 is going to be really interesting to watch and see. I don't think there is a training you can do for someone to take, like when this burst of event happens, you're doing already something else, you're already in something else. So it is going to be a pretty challenging thing, but we'll see how it goes.
So let's go to the next question.
Thank you for a great session. The question I have is, since the problem is so complex and there are so many uncontrollable factors when you're trying to predict the world around you, it almost feels like you're trying to predict the stock market in some sense. So my question is, do you see any support from the government in providing you with infrastructure that helps in, having a more controlled environment, like a rail track or an autonomous lane or something like that, and can you share some light on it?
Yeah, the star rating is one of the best example. Because the ADAS award just for the star rating. The government gives the star rating for the cars that fuel the whole ADAS exploration. Now they try to get a more star by adding extra sensor. So that is one way of doing it. A lot of universities and Arizona State is giving incentives and also giving a kind of playground to explore, giving a racetracks for the car on the environment, so you can it kind of back, where the law enforcement also get trained by this. So it kind of technology is helping government technology. So it is already happening.
So I would say again that knowing China market is again, they are taking a lead in this. They are already planning highways that would have only autonomous vehicles. So if you think about some of the projections, it is projected even for the next, I would say 25 years, at 2035, the number of autonomous vehicles that we would have on the roadways would still account for less than 10% of the total, all the vehicles, which means there is going to be human and autonomous vehicle interaction. You cannot get out of that in the US, but there are countries that are leapfrogging that by coming up with solutions where you have autonomous vehicles for a particular road. So those are running.
Yeah, we have two people here, they have a very similar question. They'll quickly specify it and then we can have somebody answer it.
Okay.
Gajendra, So the number of fatalities per mile driven is in India is way more than in US. And for me, it's a personal thing. I have lost like family, pretty close family members. Now, if you look at like, so there are out of the many reasons that we want autonomy. Like there are the two big ones are like one is safety, and the other is the financial aspect. Like if you eliminate so many drivers, like there's just so many people just driving on roads, so there's a financial aspect to that. Now, Indian OEMs are very well known for late adoption. Like they just do it like the last in the world in thermal projects. How does any of solving these problems? Like how do we see that helping this situation in India? What will get adopted? Who will adopt it? Like what's the outlook? Thanks.
Yeah, I have a similar question. Like you mentioned that most of these algorithms need to be trained for rare events, and if you are driving in India, you probably see everything is rare event. How do you think the stuff which works here is going to translate to any attempts of self-driving in other countries, especially like countries like India?
I can start. The unstructured roads and no lane infrastructure exploration already started. So there are some projects Intel India working on. They are mapping the Hyderabad city to learn what are the objects. Here we only get cars and pedestrian and bike on the road, but there you can see everything. So the rickshaws and animals and everything. So there are exploration going on. There are models, deep learning models already evolving to address unknown, untrained environment. That's level 5. So I think that is where I think India will take advantage of. I think the level 5 would be the ideal, because we can't make every city smart city in India, or even just the road. Very hard to get a lane markings and the wireless charger, or the infrastructure is expensive. So either we adopt level 5 or flying cars. Flying cars, I think if you look at it, it's very close. In Bay Area, there is already a company exploring different options and optimized motors which can carry people, and maybe that's one thing we can hope for. I think that's the...
Okay, quick answer.
I was just going to add one comment. It also ties to what Nilesh was saying about China. Over the last, 6 months, I've been trying, when I can, to talk to people in the auto industry and close to policymakers in India to try and jolt them a bit, okay? Because I know about NEO, I know many of the other activities that's happening in China, and China is trying to make huge leaps. India is far behind, and I don't think that is a good thing, personally. I think there needs to be a very focused effort from government and industry in India to really jump in and start playing a bigger role in the transformation of this space. So I personally don't think the Indian driving conditions are an unsolvable problem. I think I'm very confident between the Waymos and Cruises and all these guys, they'll figure out solutions to that. And there's a lot of smart talent in India that can help with that. I think it's going to come down more to having the level of buy-in and support, both government, industry, to make that transformation happen. And I personally feel it's not happening at the pace that's needed.
Great. Thank you so much. I think...
thank you. This was a very good panel. I think we need to give a round of applause to all of them.